Hey guys, my name is Lucian. Most of you know me. Hey guys. Together with Geo, we've created this workshop, which is based on scalable notification systems with serverless technologies. Geo couldn't be here due to a very fortunate event in his family. He's a new dad, so let's give him a round of applause. Okay, I'm a tech lead at Salt&Pepper, and yeah, let's get started. First off, let's see what's in it for you with this workshop. So first, we're going to look at the problem and the solution. Here we're going to identify the problem, we're going to look at possible solutions, and we're going to try and pick the best one. Then we're going to look at the architectural part. So we need some functional requirements. We're going to look over them. We're going to look into the tools and costs. And then we're going to piece everything together into the diagram. Let me just change my hand because this is really uncomfortable. Okay, then we're going to look at what is serverless.com and how we can set up a project with serverless.com. We're going to look into how it works, and we're going to explain the code. It's not the actual code we used, it's a simplified version. Then I'm going to explain to you how we can set up a G-Cloud, how to deploy using serverless, and we're going to look at logging and testing. Then we're going to have a quick Q&A session if there's need for it. Cool. So right now, most of modern apps, if not all of them, have notifications. Either email notifications, push notifications, in-app, doesn't matter. Anytime a user does anything inside the app, something gets triggered, a user gets a notification. Let's have this scenario, for example. We're a small startup with a limited budget, and we want to notify all of a user's followers whenever that user posts something on the app. How can we do that? Since we're a small startup, we have a monolith architecture. That's not quite ideal, but this is what we have. Because we have this, we can try and implement the notification system, but if we do that, then let's say if we have a user that has 1,000 followers, we have to send 1,000 notifications. That process is going to slow down everything, and it's going to block all the other processes. Now let's scale that up to 100 users with 1,000 followers. That's a lot, and the CPU is not going to take it, and we're going to get frustrated. Off the bat, we have a possible solution, which would be microservices architecture. But that's not really feasible for us. If we need to redesign everything, re-implement, refactor the backend, then we're going to lose a lot of time, a lot of money, and we can't really afford that since we're a small startup. So we did what any good developer would do, because we were in this exact situation with our app Prepino. We had a monolith backend at the time, and we wanted to implement a notification system fast because we wanted our users to be notified whenever a creator posts something, a recipe, for example, or an article. So what we did was what any good developer would do. We implemented our notification system with Google Cloud Functions because it was in the same ecosystem we were already using. Okay, let's look at the functional requirements for this. First off, we're going to talk about coupling. Does anybody know what coupling is? You don't have to say, you just have to raise a hand. Okay, cool. So for those that don't know, coupling means when two entities are in sync with each other. So the degree of which, with which they communicate. We don't usually want our system to be coupled. We want it to be loosely coupled. Why? Because if we couple it, then in our example, we send a request to the notification system in serverless, in the Lambda function. Then we have to wait for a response from it. And that could take a while. That's why we try to decouple it using a number of different services. For example, we could use queues, we could use pub subs for queues, we could go with cloud tasks if we're in the Google ecosystem, or AWS SQS, or even Apache Kafka. And for pub subs, we could go with Google pub sub or AWS SNS. Because we're gonna work with Google, then we're gonna choose Google PubSub. We actually implemented this for Prepino with Cloud Tasks, but we're gonna go over to Google PubSub. That's why I'm gonna present it with Google PubSub today. Okay, let's see how the PubSub works. For those that don't know, the PubSub stands for Publish and Subscriber. So we have a message that's being published to the PubSub, to the topic, and that topic is triggering something using the message. So most likely we're going to have issues here. These are our limit points. And we have some. We have a maximum size of 10 megabytes for messages. But there's another thing here, the minimum size. And it's not the usual minimum size, because when we usually think of a min and a max, for the max it's obvious. You can't go above it. But for the min, you can actually go below it, but you will still be charged as if it was 1 kilobyte. So for example, if we have a body that's 5 bytes, then we would be charged for 1 kilobyte. So Google actually advises that we use batching of messages if we have bodies below 1 kilobyte. Right now, in this example, we're not going to bother with that. In a real scenario, you're gonna reach the 1 kilobyte target. Another notable thing is the response time. So whenever you publish something to the queue, you will get a response for it. And the response time for this is 100 milliseconds. Like I said, if we want to communicate without decoupling the whole system, and we send a request to the function directly, then we would have to wait for it to respond, and that could take a while. In our example, our functions tend to go around 1.5 seconds of lifespan. So that's why we're going with PubSub for this. Okay, like I said about functions, we could have used any other function, for example, Lambda, or even DigitalOcean's cloud functions. We are going to use Google Cloud Functions, and we have to be careful of multiple things here. For example, the first one, which I think is kind of the most important of them all, is the cost. When we're talking about Google Cloud Functions, we are talking about three ways in which they charge us. The first one is how long the function runs, how many invocations of that functions there are, and how many resources we're provisioning for this function. In this specific order. So our top priority, our number one priority, will be to keep the length, the lifespan of this function as short as possible. Other things to note here are the hardware limitations. So for deployments, we have 100 megabytes of compressed deploys, and also they have 500 megabytes for uncompressed deploys. The lifespan for the Gen 1 function is 540 seconds, that's around 8.5 minutes, and they can go up to 10 minutes for tier 2. We're going to be using tier 1 because it's out of the box. We also have maximum concurrent invocations of 3,000 functions, and also 1,000 functions per second maximum invocation rate. We are good to go so far because we kind of fall into these. If you want, we can talk later about how we can overcome all these problems. Okay, next up. Since we have our top priority, which is keeping the lifespan as short as possible, we don't want our whole code to be run in a single function, because that would defeat the purpose, it would be very costly, and we will be frustrated again. So we're going to separate everything. Using the separation of concerns principle because of what I said earlier with the time. And also, there's another reason. We want to keep it neat. We want to keep it tidy. We want to debug it easily and maintain it easily. So that's why we're going to separate it into a generator service worker, which is going to be basically a worker that gets from the message. It gets a query. It finds all the users that are being targeted for notifications, and then the email notification service worker, which is going to send each and every user notification. Then we're going to have to pick a database. We went with MongoDB because it's easy to set up, easy to use, and we really like it. I'm not being paid to say this. I'm not sponsored by them, but I wouldn't mind it. since they're here. And we're going to go with email service Sending Blue because they offer 300 transactional email free per day. And because I had an implementation of it laying around and I had to put it to use. Okay, let's look at costs. For the pub sub, we have the first 100 gigs of throughput per month for free. For the cloud functions, we have for the compute time 400 gigabyte seconds and 400,000 gigabyte seconds compute time, and also 200,000 gigahertz seconds, same for compute time. And also, this is the big one, 2 million invocations for free. This also applies to AWS. I'm not really sure about this, but it kind of goes the same way. Also, Cloud Build, which is an API we're going to use from Google Cloud for building our project and deploying it as functions. The first 120 minutes per day are free. And like I said, Sending Blue with 300 transactional emails per day free. And Mongo has one free cluster per Atlas project. It's going to boil down to $0. So this is really good for us because, like I said, we are very, very poor, tight budget. Okay, so we have the costs, we have the tools. Now let's see the big picture here. This is what the diagram would look like. We're gonna send the message to the pub sub, to the topic, either through API or Cloud Console. We're gonna go with Google CLI in this example. And we're gonna send a query and let's say a notification type. That query is going to trigger the service, the generator service worker, which is going to find all the users based on that query. And for each and every user, it's going to trigger another cloud function through the notification pops up. That cloud function that's going to be triggered, it's the email notification service worker. And that function will send the email through a third-party email service, Sending Blue in our case, to every client. Okay. Now, in my experience, all the problems I had with cloud functions were with deployments. The first time I started with them, I had a really hard time. It took me like 5 days to deploy one function, and it got really frustrating. And a colleague of mine told me about serverless.com. Anyone heard about serverless.com? Cool. Oh, jumped a bit. So serverless.com is a framework which builds and deploys cloud functions. It was initially created for AWS Lambdas, and I highly recommend it with Lambdas because it's really fun, easy, and it's kind of a piece of cake, to be honest. But it also works with other providers, other cloud providers. For example, we're going to use it with Google, also works with Azure, works with Alibaba Cloud, if anyone has ever heard of it. Yeah, and many others, many others. So let's see how we can set up a project with serverless.com. First off, we have to install it globally, and that's pretty easy. We've all done this. We have to create a new service, and we're going to run serverless create template. We're going to use Google-Node.js, and we're going to pick a path for our service. And then we're going to install the dependencies by changing our directory to the new service and installing everything. Now, when this finishes, we're going to be left off with a very interesting file structure. We have node modules, index.js, package.json, package.lock.json, and serverless.yaml. Serverless.yaml is the main file from the whole project. So it's basically the heart, the brain, the everything for this project. We have here everything serverless needs in order to successfully deploy our functions. We have the name, the provider, which would be Google in our case, stage. So this is actually right out the box. I only removed some comments. Runtime in our case here is Node.js. We will be using Node.js 16. Region project, which will be the project name from G-Cloud Console. Credentials, we're going to get into that a bit later. Framework version, this is the latest one. Plugins, this is really fun because serverless has a lot of plugins we can use. In our case, we will be using serverless Google Cloud Functions and also serverless Webpack because we're going to be writing ES6 and we want it to be translate it into ES5 so the servers can run it. The package just tells the serverless framework that we don't want to include node modules, git ignore, anything related to Git. And then the last part is the functions. Here we describe the functions, and it works like this. This is the name of the function that's going to appear in the Google Cloud Console. For the handler, oh, 1 second. Okay. For the handler, this is actually a function that is going to be inside index.js. So this is going to actually run. This represents the code. And for the events, that means how the function is triggered. This shows that the function will be triggered with an HTTP path. So basically, when we type in a URL and we are authorized to use it, then the function will trigger. Okay, let's take a look at the index.js. Here we have the HTTP function I told you about with a simple response, hello world. And we also have an event. This was commented in the serverless YAML. This actually works multiple ways. So it's not a URL, but it's triggered with an event. For example, like we're going to be using with topics from PubSub. Okay, let's see the actual code. I've prepared some code here. I don't think anybody can see that. Let me just... Okay, so let's start with the YAML. 1 second. You can all see, right? Cool. So, like I said, we have Node.js 16. We chose a region. Fun fact about this region, it's actually, excuse me, eco-friendly. It produces way less carbon dioxide than any other region in Europe. The project name, which is taken from gcloud. I'm going to show you later how to set up the gcloud. Credentials, again, later. We also have an environment file. This is for the environment variables. Like I said, plugins, serverless Webpack. The rest is basically just basic configuration for Webpack. The packages exclude, like I said. Let's get into the functions. This is really fun because here you can see a lot more than I showed earlier. We have 2 functions here, the decomposition service worker and the email notification service worker. For the decomposition service worker, we have the same name for the handler. And for the events, we have the event type as a topic publish. So basically, this is telling the function that whenever that topic receives something, because it is subscribed to the topic, it's going to trigger the function. And the resource we're talking about, the actual topic, is going to be project dash our project name taken from here, Techsylvania 2022 dash slash topic slash decomposition topic. And the same thing goes for email notification service worker, except we have a different topic name because we want them to be triggered differently. Okay, let's get into the index. Here we have the 2 handlers defined. So let's start with the decomposition service worker because this is actually the first step in our whole, I'd say journey, but it's not really a journey. Okay, first off, we're gonna try and make a Mongo connection. Fun fact about how serverless functions work. The first time I've developed a function like this, I kept creating new connections. And the connection don't disappear. They stay there. So whenever a function is invoked, they have an internal cache. And the connection doesn't die out. So after about 500 function invocations, we noticed that our free tier Mongo is having troubles because we are going over the 500 connections they had. So after a lot of research, we found out about the cache thing. So this is how we actually got it to work. We define it here as a global variable. And inside this function, the setup and get Mongo connection, which I'm going to show you right now. Repository Mongo here. We check the cache DB. If it exists, then we return it. And if not, we create a new connection as a promise. So that's pretty straightforward. After we have the connection, we have to get the DB models. In our case, it's just the user model, and it's on the same idea because they get cached as well. We just return the user. That's the only thing we're going to be using. Then the data. The data that comes from the message that we send to the topic is going to be stored as a base64 buffer. We want that to be transferred in, as a string, but that string is actually going to be a JSON. That's why you have to parse it and get it. I've tried different approaches for this. None seem to work. If you have any other approaches, please let me know. I will be really happy to implement them. We're going to log this information to see it. We're going to look into that later. And then we're going to get into the decomposition service worker, which is defined here in the functions. And this is a rather simple function. We just get the data. We're going to have notification type and target aggregation. Inside the target aggregation, we're going to have two objects. First one is going to be the target model. So the target model in our case is going to be users. And we're going to have another object, another property called steps. Steps is going to be an array of aggregation steps, for those of you that know Mongo aggregations. This could be replaced with queries if we're going to use any other database. But in our case, we're going to with aggregations. So we're going to get the targeted users, DB models, which is just an object that contains all the models we have described here. In our case, user. It's going to get the target aggregation target model, again, user, and it's going to aggregate based on the steps inside the data. And we execute it. We're going to get an array with users, so we're going to have IDs, emails, names, everything we need, trying to avoid any passwords or stuff like that because we don't really need those. And using Bluebird's promise. Does anyone know about Bluebird promises? Okay, so Bluebird promise is something like promises on steroids. We can actually use a promise map which takes as parameters a target, an array, and a function for that array. So we have the targeted users. We can define the async function using a single item. We called it targeted user. We're going to define the topic and we're going to publish to that topic. Our message is going to be the notification type, which is coming from data. And for the user, we put targeted users. Now, why did I use promise map? For simply this fact. We can set a concurrency. So basically, we can set 10 concurrent executions for each for this array. So basically, this works like so. We have 20 users. 10 users get automatically targeted, and then whenever a topic gets published, then it's going to end the function. A slot is going to free up. So instead of 10, we're going to have 9. Another one comes in. So it's not 10, they finish, another 10, they finish. No, it's always going to be 10 until we run out of space. We run out of elements in the array. So now the information, the message is published to the topic, which is the email notification service worker, which is the next step in our pipeline. It's going to get triggered by this here. And it's going to trigger this function here. we just get the message, same as before, and we call the function to do the work. This function just takes the data, which will be user and notification type, and using a simple function like the one I told you that we had lying around, we send to an email, which we take from the user, the name from the user, the subject, which is going to be notification type, and the content, in this case, is going to be welcome to my high five page. And we log the response. Okay, pretty straightforward, right? Let's deploy this. Let's see how that works. So for deployments, we're only going to go SLS, which stands for serverless. We could also type in serverless and deploy. This actually takes a while, so I'm going to continue the presentation. I'm going to talk to you about how to set up the Google Cloud console. So creating a project in Google Cloud is pretty simple. All you have to do is go into the hamburger menu in the top left, go into IAM and admin, and hit create new project. Then you input the name, organization, location, everything, and hit create. So far, so good. That's the first step. Then we have to activate all the required APIs. In order for our serverless to work, we need some APIs. There are 3, not many, and they're all free. To do that, we go into the search bar, search for APIs and services, click on the first thing that pops up. It's going to be a page. Brings us here. We go into library, and then we install the 3 following things: the Cloud Deployment Manager v2 API, Cloud Functions API, and Cloud Build API, the one I told you about earlier with 120 minutes. Cool. We have the APIs secured. One thing to look out for, whenever you activate Cloud Deployment Manager v2, the first time you run the deploy, it's not going to work. It's going to show an error. So you have to run it again. I don't know why. Every time I do it, it does that. Then we have to create a service account for deployments. Now, in case you don't know, we don't want our main account, our admin account, root account, whatever you want to call it, we don't want that to be publicly displayed or even kept as a secret in our pipelines, because if that gets in the wrong hands, it could do some serious damage. So we're going to create a simple account that is, its only role is to deploy our functions. We could do it for anything, for storing objects in a bucket, for taking out objects, for absolutely anything. So in order to do that, we go into the hamburger menu again, IAM and admin, service accounts, and create service account. Then we input the name, and the service account ID gets filled in automatically. And this is where we have to add the permissions for it. This is the same for AWS, same for any cloud. It's a very important principle. I keep forgetting the name, but basically you don't want to give it more access than it absolutely needs to. In our case, we're going to need Cloud Functions Developer, Deployment Manager, Deployment Manager Editor, and Storage Object Admin. We don't need more. We can't work with less. Okay, then we hit done, and it's going to create it. Next, we have to get the JSON credentials. We will need this in order to put them inside a folder on our project so we could use it for deployments later. We hit the newly created service account. We go into the keys tab, and then we're going to go to add key on the bottom left, create new key. A new modal is going to pop up with the key type. We're going to select JSON, and then we're going to hit create. And now we have everything. So let's talk about how deployments actually work, because serverless is quite common the way it works. If anyone has heard about CloudFormation from AWS, cool. So basically, the serverless framework parses the serverless YAML, finds all the resources, it creates a directory, and then it zips it. Then it ships it out to the deployment bucket, and it deploys all of the necessary things we need. So for example, in our case, it's going to create the functions, and it's going to create the triggers, which are the topics. Okay, let's see if the deployment is ready. bit more to go. We're going to talk about testing. So in order to test if the function works, you could either publish a topic, publish a message to a topic like I showed you earlier via your API or backend, whatever, or you could do it from your bash using the gcloud CLI. So the gcloud CLI is really useful. You have to install it globally, then you log in into it and select your project. And after that, you can just gcloud pops up topics publish. We put in our topic and our message. We are going to use a JSON format, a JSON stringified format. Let's check on the deployment again. Okay, so it's successfully deployed. And we're going to put in this command. I don't know if you can see it really well. So basically, this is what we're saying. gcloud pops up topics published to the decomposition topic. And our message is going to have the following things: the notification type, which is new promotion; targeted aggregation, which will have the targeted model user; and the steps. These steps basically describe that we are going to look into the users table and we're going to find the only user that matches this ID. And this is my ID from the database where I have my personal email, and it's going to send me an email with that notification type as subject, and the message should be the one with high five. I'm going to send this. We get a successful response here. Now, let's check out the logs, because that will be the next step. We can find the logs if we go here into functions, cloud functions. Then we can select any of these two. I'm going with the first one because if you remember, we have a console log there to see the data. We go into the logs tab. And here you can see if we refresh, I think this is the last one, yeah. So this is the console log. This will not show up here because this is only as a string. In order to see it, we have to go in the Logs Explorer from here. You can actually access it through anywhere else on the cloud console. I usually do it from here. Then we click on this, and inside the JSON payload, we can see the notification type, target aggregation with all the steps, everything here. Yeah. Okay, let's see if we received an email. And as expected, we have a new email here, which is, I don't know if you can see this, welcome to my high five page. So yeah, it was kind of expected because it was only one user. But the beauty about this is that it can be extended to a lot of users, and we don't really have to worry about anything because once you deploy this, it kind of works like magic. You can also, we used it with Firebase notifications. We plan on putting email notifications soon into it, so we're going to use this exact same structure. Here you have a QR code where you can find a Git page, a Git repo with the notification system I've showed you. You can use it to implement your own or use it to extend any function you want. So yeah, that's about it. If you guys have any questions, I'm happy to answer them. Thank you. Okay, so no questions, then see you at the afters.